Hi, myself Sai, and this is year 2025, also the first day, January 1st. We had a nice new year, it's all done. Now, I'm working as a software engineer. It's been 3 years in the industry, and I will be shifting to another company this year, hopefully, if everything goes well. And right now, I've been involved in so many great projects, AI related, LLM related. I am into chatbot and all those things. So you can say I'm a person who's riding this AI wave, and I should say this is very AI is in its infant stage. Yeah, it's in its infancy. A lot more can happen, and at the same time, lot more can go down. There's no certainty in this. But me being a curious soul, I want something more in it. I want to um, know more on this. I want to, understand the where, why, what, how, those kind of questions. So keeping that all in perspective also, I'm planning to, do my PhD in this related field. There are so many great things happening. One side we have quantum computing, and one side we have this AI, and at the top we have the um, a extended reality, artificial augmentation, and all those things. So yeah, there's a convergence going on here. So many industries colliding. We can say a singularity is very very close. Though the singularity term is completely different in quantum, they are using it for something. But yeah, I'm not, I'm no one is brilliant. I'm just at the starting. So what am I doing here right now? So as an precursor to everything, I don't want to miss this first day itself. I wanted to register myself here. So here I am. Obviously, as the name suggests, I am chasing behind the origin. What is it? What's going on? So here and there, I have this box with Alan Turing, 1912 to 1954. We all have seen that Imitation Game movie, right? As the movie unfolds, we are very much. They make us very familiar with the box and dial kind of setup where Alan keeps on working and he keeps on pushing and he keeps on wasting the energy of others telling or trying to explain but they don't understand it. Yeah. So let's see what it is. So there is a very famous paper on computable numbers with an application to the end shadings problem. I'm not sure if I'm correctly pronouncing it, but it's end shadings problem. Yeah. Um, this is a 36-page paper. Okay. Um, you see, if you go word by word everything on this, you will not understand completely. Even I don't understand, especially this mathematical symbols and everything. But yeah, if you put your head to it, it's very simple. It's very easy. The the fact that it is very easy is the thing that we have so much technology at our expense. The way we are able to send the text messages, the way we are able to process information in our day-to-day system, it's all in its core has this Turing machine phenomenon. Not exactly Turing machine, there is von Neumann's architecture following this Turing machine, but yeah. So I'll try to give a preface to this. There's a lot more to learn with this paper. I will try to give a preface. So let's go with a uh, simulator. This is a very very interesting simulator which I have here. Let me try to load a simple example. Binary number divisible by 3. All right. So you see this, right? You just see this box, right? In this box, what they call it as a tape. And in this paper, if you go in this paper, there are some assumptions. Yeah. One thing to mention here is this paper, when it was published, it was just purely theoretical. It just, it's not like something, machine. was there and machine was used, and then based on the machine this paper, no, it was not like that. Rather, this paper was made first. This paper came into existence, and based on this paper's theoretical aspect, machines were tried, different realization of the concepts of the crux of this paper were realized. And one possibility is with the tapes, uh, infinite tapes, registers, dials. So one such tape is this, and in each tape there is this pointer, this cursor. You can give it a name, whatever name, and this is supposed to move each stepwise. And on its each step, whatever is program written here, illustrated here, this will be checked. So whenever this cell moves, whenever this cell shifts, the another cell will have its own instruction, and based on that, some arithmetic, right? So to begin it, I am doing this. Let's say binary number divisible by 3. Let's give it 3. If you go to this website, you will be able to convert a decimal number to its binary equivalent. I have entered 3 here. When I convert, I get 1. Let's enter it. So now I will just do this. You can see, it says that's it. It's, the decision is made now. Is it accepted or not accepted? If you show output, it says accepted. Okay. Let's say if I give 2 on 0, right? Rejected. So the whole concept here is just this guys, just this guy accepting and rejecting. Yeah, there are some other examples here which you can try, all these examples, but yeah, what I'm telling here is that's it. A decision is being made. The fact that you will not be able to realize it at the first go, but I would suggest you to really think through it. This is what we are talking in the year 1936. You will not be able to realize what will be there at that time being here in this 2025. Yeah, 2025. So give it some time, read this paper, and try to read other events. I will try to gather some more events during this period. Received 28 May. Yeah, and you will be able to appreciate what we have these days. Let's try some other example. Binary palindrome. What is it? So a binary number accepts if any is palindrome. Example accepts 1010. Oh, let's compile this. Okay, it should accept this number, right? 10101. You can see this, right? It's a beautiful illustration. Let's give it this. Yeah. Um, why? Um, why do one needs to understand this? Why do one needs to go to this extent of checking if there is a Turing machine simulator and load this program check? I would suggest this is very important if you consider pursuing a research or doctorate in the field of computing. Um, if the basement is strong, if the roots are strong, the upcoming concepts or the advancement in technology, you will be able to understand it very easily. I'm not saying there is a, this is not like, apple to apple conversion. This is not a cutting edge technology which you're learning, but what I'm telling you is, the intention matters. What with you, one should understand always what might be the intentions that, Alan might have come to this conclusion, like this kind of realization. And also another thing, right now, whatever is going on, this Turing machine is the, base for everything. And Alan Turing is considered, the father of modern computing. Right now, my even a further step, if you want to understand how it works, there's this another amazing illustration of how things work. You can see this. So all this paper will tell you is, how a machine can be considered, which will be able to solve this one problem, end shadings problem. End shadings problem, if you search it, you will come to this part where, it's a problem where, finding the way to decide whether a formula is true or false within a given system. See, this can be realized very easily in today's programming language by any kind of conditionals, condition, if loop, for loop, while statement, anything. But at that time, here we are talking about where these kind of loops were not there. They were not realized yet. And at that time, if you read this paper, you will understand how, yeah, you can go down what is this problem, and what is the roots for this. If you go down, at times when we get stuck in at times when we get stuck with some bugs or errors, we go down the rabbit hole, and in order to cut short, we try to avoid that rabbit hole. But one place where you should definitely go down the rabbit hole is this kind of research papers. You should try to understand each and everything. They are beautiful. A person like me, I'm fascinated by all these things. This gives me that, highs. You can think of it like that. I will. So what I have decided this year is, weekly to get 2 or 3 videos per week. That's my goal. And I'm not sure if I will be able to do that, but I don't want to miss this day, this January 1st. That's why I started with this. I'm totally unprepared. I'm not at all prepared, but I wanted to get this done. It's like, I wanted to start the uh, steps. So, yeah, I hope I didn't bore you guys, but I will try to make it a little more interesting, showing more codes or, finding some interesting facts, which will be very nice. Happy New Year to all. Thank you.